Now let us look at the next question on the board. It's about a student. A student can answer 8 questions out of 10 in an examination. How many choices has he? So you've got 10 questions and the student is required to select 8 of them to answer in an examination. How many possible ways can the student select his questions, alright? So there's a combination problem because it deals with selecting a given number of questions out of a total of 10. Now there is no condition imposed on this problem, no condition, is that okay? No condition, so the student can select any one of the questions. Therefore, we're given that n is equal to 10, there are 10 questions. Then r is to select 8 questions out of the 10. Are you following? So since there is no condition imposed, we can apply the definition of combination directly. We indicate no condition is imposed. No condition is imposed. No condition is imposed. Hence, apply n combination r. N combination r, is that okay? Now, n combination r, we have the formula already, the n factorial all over n minus r factorial r factorial. So 10 combination 8 is going to be 10 factorial divided by 10 minus 8 in bracket factorial. Then we're going to have 8 factorial. Now, when we expand 10 combination 8, the numerator 10 factorial, I'm going to expand it up to 8 factorial because I've got 8 factorial in the denominator. Alright, so this is going to be 10 times 9 times 8 factorial. So I'm going to divide this by 2 factorial, which is obtained from 10 minus 8. Then 8 factorial. Can we now see what divides? The 8 factorial can cancel out. So this goes with this. And if that divides out, you'll agree with me that we're going to get 90 divided by 2. Alright, 2 factorial is the same as 2. Normally, in exam condition, I don't think it's necessary to do 10 times 9. We could have divided from here straight. Are you following, right? 2 factorial is 2. 2 can divide to 1. 2 into 10 will give you 5. 5 times 9 will give you 45. That will be faster in order not to create a bigger number, in order not to get a bigger number such that division might be painstaking or tough to do. Dividing 90 by 2 is tougher than dividing 10 by 2. Are you following, right? So that's best. You could have divided from here straight on. 10 combination 8 would now give us 45. 45. So there are 45 different ways the student can select, alright, his questions. Let me make the statement here. Therefore, there are 45. There are 45 different ways. The student can select 8 questions out of 10. Is that okay? So take note, we applied the combination formula directly because no condition was imposed. The question could have been a situation where they say, okay, that one particular question must be part of it, or one particular question should not be part. Because if that becomes the case, then we need certain principles of combination. But for this problem, this is how to approach it. And of course, we've got our answer to be 45 different ways. Let's now consider this next question on the board. A committee of 5 is to be selected from 6 science and 4 non-science students. How many committees are possible if at least 1 non-science student must be included? If at least 1 non-science student must be included. This is a conditional combination problem, right? Because we have this number of students, 6 of them are science students, 4 are non-science students. We are to select 5, students. which must be drawn, which must be picked, which must be taken from science and non-science students. Now the condition is that however you were selecting these 5 students from these 2 groups, are you following right? One of them at least must be a non-science student. So you could have either one non-science student in the 5 persons drawn or 5 students drawn from the 2 groups. You can have more than one non-science student, is that okay, drawn from that group. Does that make sense? So with this condition, we have to know how to approach this problem. One really don't need to memorize the formula of conditional combination, using the principle of if at least a particular person must be included. It's really not necessary. Memorize the formula n-1 combination and r-1. One can do the analysis of these in real life situation, and that's what we're going to do so that we get our results. But first, let's bring out the data, what we know from the question. Number of non-science students, let's say the n science. Alright, okay, number of science students is 6. And then let me use n non-science. Alright, following right, n subscript n to represent non-science. We've got 4 students there. We've got 4 students. Now the committee is to be made up of 5 students. In our selection, the committee is to be made up of what? 5 students. Which means if I pick from this 6, pick from this 4, at every point in time I should get how many students? 5 students. And take note, there is no room that you can pick all the students from the science without non-science student being there. Because the condition was placed, there should be at least one non-science student. So just think about this. If there should be at least one non-science student, it means all 5 students can never be science students. Are you following? All 5 students can never be science students. Am I communicating? The highest number of science students you can have in any selection is 4. Because if you get 4 science students, then you pick one non-science to make it 5. Then if you have, let's say, 3 science students, you pick 2 non-science to make it 5. And when you have 3 science students, or let's say you have 2 science students, you have to pick 3 non-science students to make the list 5 at every point in time. Alright, committee of 5. Committee of 5. Committee of 5. At least one must. Let's say 1 out of the 5. 1 out of the 5. The 5 students. 1 out of the 5 students in the committee. Students in the committee must. It's not may. Because I say must be a non-science student. A non-science student. A non-science student. So let us see how this combination would go in order for us to get this committee of 5. Are you following? Now this principle goes in line with probability. It's quite important for you to know that combination and probability, they work hand in hand. Is that okay? So let's go. This is going to give us, in the first case, let's say that you have, out of the 6 science students, you picked 4 of them to form the committee. Then it's going to be 4 out of 6 science students and 1 out of 4 non-science students. Are you following? Mathematically, in terms of probability, when you have and, you use multiplication. So in the first selection, we would get 6 combination 4 times 4 combination 1. Is that okay? Then there is still an alternative way, of selecting this. We can choose to say, okay, out of the 6 science students, 3 should be selected. That is the second draw, 3 should be selected. So out of 6, you're picking 3, you're selecting 3. In that case, out of the 4 non-science students, 2 will be selected. Remember, the condition is at least 1 non-science student. So you can have 1 or more non-science students. And this is going to give us 6 combination 3 times 4 combination 2. Then in the third case, it could be that out of the 6 science students, you select 2, and then the non-science student, out of 4 of them, you select 3. Take note at every point in time as you add these terms. Are you following? The R term, you should get that committee of 5 students. Are you following, right? Anytime you add this down part. And whenever you add your top part, that is n, you should get a total number of students, which is 10. Does that make sense? Alright, so this is going to give us 6 combination 2 times 4 combination 3. There is still another possibility. The possibility is that you have 6 combination 1. That is to say, out of the 6 science students, you select only 1 science student. And in that case, out of the 4 non-science students, you're going to select 4 to make it what? 5 students. This, of course, will give us 6 combination 1 times 4 combination 4. Take note. And, as used in combinational probability, means multiplication. So these are the possible ways of selecting this committee of 5, such that in the committee you would have science students, you would have non-science students. But the point is, at every point in time, you should have at least 1 non-science student. So you can have more than 1. And take note that there is no room for you not to have any science student at all. There is no room for that. You must have a science student, you must have a non-science student in this committee. And that is why we cannot bring this to 0. Are you following? We could have thought about doing 6 combination 0, but it's not possible in this case, because if you do 6 combination 0, it means out of the 6 science students, no science student is allowed to serve in that committee. But of course, there is no such statement in this question. All these 2 groups, science or non-science students, somebody must serve from it in that committee of 5. So this will now give us equal to, we now want to combine all these things. So 6 combination 4 times 4 combination 1 plus, so this is the first case. So it's either we select them in this way, or the selection will be in this way, or the selection will be in this way, or the selection will be in this way to arrive at the 5 committee. Is that okay? And in mathematics, combination of probability, or the mathematical sign used for that is plus. And that's why we have this. Then this is going to be 6 combination 3 times 4 combination 2. Or the third selection, 6 combination 2 times 4 combination 3. Or the last possibility is 6 combination 1 times 4 combination 4. You see, in this 4 combination 4, we have 4 non-science students, selected to serve in that committee. So when we work at this, 6 combination 4, if you work it out, you have the formula already, you're going to get 15 times 4 combination 1 is going to give us 4. And then plus, come to this, work it out, 6 combination 3 would give us 20. And then multiply by 4 combination 2 will give us 6. And then 6 combination 2 is going to give us 15. It will have the same value as 6 combination 4. Remember, 6 combination 4, 6 combination 2. We did something about complementary combination. Is that okay? Yeah, if you have a number combined with another one, that's a number combined with a different number, such that what they are combining with, if you add them together, you get n. It means that combinatorial terms are equal. So 6 combination 2 is equal to 15. You're going to multiply it by 4 combination 3. And 4 combination 3 will give us 4. Then lastly, 6 combination 1 is equal to 6. And then times 4 combination 4 will give us 1. If you work in this, you're going to get 246 ways. Are you following right? So a committee of 5 is to be selected. The question is, how many committees are possible? So 246 committees are possible. So if you to follow this condition, then there are 246 different committees that you can form. Are you following? Having 5 of the students to serve there, some being science, some being non-science, on the condition that a non-science student must be included.